this video, we're going to talk about multiplying polynomials. If you don't know what a polynomial is, check back at the previous video labeled 10.1 that talks about what polynomials are and how to add and subtract them. First up here, we actually probably at this point, if you're going through an Algebra 1 course, already know how to multiply some polynomials together using a property called the distributive property. This property is usually introduced in pre-algebra and then maybe talked about at the beginning of Algebra 1, and then we're revisiting it now as we think about multiplying polynomials together. The distributive property says if I have something outside of a set of parentheses where the operation here, since it's right next to the parentheses, is multiplication, what I can do is actually just multiply both of these things by that outside number and get rid of the parentheses, which is something that we typically like to do in math, is try to get rid of parentheses. So in this particular example, I would do 5 times 2x. The way that works is the 5 and the 2 multiply together, and the x just comes along for the ride, so that this is 10x. And then 5 times negative 8 is negative 40. And so by distributing that 5, we get 10x minus 40 as our answer. So that's the kind of thing we're going to be doing today. There's going to be a little bit of variation here and there. For instance, we'll make problems longer or a little bit more complicated, and we'll see how that works. So here on this example, we have 3x squared. We're going to multiply it times all 4 of these terms that are inside. Now, a reminder about what happens when you do something like 3x squared times x cubed. So our normal numbers multiply together, like 3 and the 1 that's right here would multiply and get 3. The x squared and the x cubed, when those multiply together, we add their exponents, because this is x and x, and this is x, x, and x, and so together we have 5 x's, which is x to the 5th. The shortcut is to add our exponents together instead of having to write it out and count every time. So just distributing this first one gives us 3x to the 5th. Now, you'll see people draw these arrows up above. Some people will do all the arrows at the beginning and then go through and multiply. I like to draw arrows as I multiply, because the whole point is to keep track that you really are multiplying everything. If you just draw the arrows ahead of time, you can still forget to multiply something because you're not keeping track. So 3x squared times negative 4x squared. The 3 and the negative 4 make a negative 12, and the x, I forgot the x squared here. The x squared and the x squared, we add the exponents and get x to the 4th. And then we keep going. 3x squared plus 7x. You may not need to write it out, or hopefully as you get the hang of it, you won't need to write out each step. But if you're having trouble initially, this can be helpful to let you visualize. We do 3 times 7, which is 21. X squared times x, which is really to the first power since there's no exponent, is x cubed. You can't do x squared times x and get x squared again. That doesn't make any sense. It has to go up to x cubed. I didn't actually multiply. 7 times 3 is 21. X cubed. And then finally, since we're keeping track here, it's easy to see we still have 3x squared times negative 2. And so 3 times negative 2 is negative 6x squared. So here is our answer. And that's it. Now let's make this a little harder. So if we look at what we have going on here, it says in the instructions to use the distributive property, but we don't have just one thing in front of a parentheses. We actually have 2 terms, a binomial times a trinomial. So what we want to do as we work this out is we actually are going to distribute twice, because we're going to take the x and distribute it to everything in the second parentheses, and then we're going to take the 9 and distribute it. So the way I write this down is going to help me keep track of different things that I'm doing. I'm going to do x times x squared, which is x cubed. And then I'm going to do x times negative 2x, which is negative 2x squared. And then I'm going to do x times negative 6, which is negative 6x. Now I'm going to do the same thing but with the 9. And when I multiply, I'm multiplying it through the second parentheses. I'm not multiplying it through what I just got. That's important that we distinguish that. I do 9 times x squared, which is 9x squared. I can either write it right here out to the side after the negative 6x, or I can write it underneath the other x squared because I know that my x squareds are going to be like terms that I'll have to add together on my next step. Here we have 9 times negative 2x, which would go underneath my other x, and then 9 times negative 6. When you do that, if there's not anything it matches up with, you can just write it out to the side. And then because of the way I wrote it, I can add down in columns. So the x cubed doesn't have anything to add with. Negative 2x squared plus 9x squared is 7x squared. Negative 6x plus negative 18x is negative 24x. And the negative 54 doesn't have anything to add with, so it stays the same. And B is going to work similarly. So if you think you have the hang of what we did on A, I recommend you pause the video and work it out yourself, and then restart the video when you feel ready, and skip ahead if you want, or listen to the explanation either way. We're going to take the 2x squared and multiply it with the x squared, which is 2x to the 4th. And then 2x squared times 3x is 6x cubed. And then 2x squared times negative 4 is negative 8x squared. That's the 2x squared distributed. Now we're going to do the negative 5. Now when I go to write this, I'm not going to write it under the x cubed because I'm not getting x cubed. I'm going to write it right here, which shows as I keep going that we only actually have one set of like terms on this one, which is not the same as we had over here on A. So the only thing that we can add together is the middle here. Everything else stays the same. So there's our answer. So if you pause the video and then jumped ahead, this is what your answer should look like. It could be in a different order, although the order I have it in is standard form, so it's really the best way of writing your answer. And some teachers would probably be nitpicky about you writing it in standard form, but this right here is our answer. Now, there is a special case. What we just did on example 1 and example 2 works for any problem you have where you're multiplying two polynomials together, no matter what size you have. So if we had like a trinomial and a trinomial, so 3 terms and 3 terms, we could do the same process where we're distributing each of the terms in one to all of the terms in the other. But there is a special way that we can remember how to do binomial times a binomial, which is called the FOIL pattern. Now, that is an acronym. FOIL stands for first, outer, inner, last. And if you're worried about misspelling FOIL, as long as you have an O and an I, it doesn't matter what order, because you'll still end up with the right answer. So when it says first, outer, inner, last, it's trying to tell us which terms we need to multiply together. So for instance, first is the first term in each parenthesis. So I'm going to take the 2x and the negative 4x, and I'm going to multiply those together for f. So that's negative 8x squared. Then I'm going to do outer. So the outer terms here are the two that are farthest outside. So the 2x and the 1. So that's just going to give me 2x. The inner terms are going to be the opposite, the two that are closest to the inside of the problem. So that's negative 5 times negative 4x, which is positive 20x. And then my last term in each is the only two I haven't multiplied together yet, but also it's the last term in each parentheses. Negative 5 times 1 is negative 5. So 2x plus 20x is going to give us 22x. Those are our like terms, and in general when we FOIL, We want to look in the middle because the outer and inner terms most of the time will be like terms. So we want to make sure we check for those like terms to add together. So again, if you feel like you've got the hang of this is a good place to pause and check that out for yourself. I'm going to go ahead and keep going with my explanation. All right, so first is x times x, which is x squared. Outer is x times -7, which is -7x. Inner is 5 times x, which is 5x. And last is 5 times -7, which is -35. We want to add these middle terms together because they're both x's. So x squared minus 2x minus 35 is our answer. Now there's another way of doing this other than FOIL. And you might have thought of that already. Maybe you were thinking, well, can't I just do what we did on the second example? And you can. And in fact, this is going to look the exact same and is going to feel the exact same as what we just did with FOIL. We're just thinking of it a different way. And your teacher can't actually make you necessarily do it one way or the other. You need to figure out what works best for you, because literally you're doing the same thing either way. If I use the distributive property instead of thinking of it like FOIL, that means I'm going to take the x and times it by the x, which incidentally is what we did first in the last problem. Then I'm going to take the x and do times -5, which is technically our outer terms. And then I'm going to take the 2 with the x, and then I'm going to take the 2 and the -5, which was the inner and the last terms. And so I drew arrows differently. I didn't have to think about first, outer, inner, last, although I mentioned it so you could see the connection. And we can still come up with the answer. The middle terms are still most likely to be like terms. And here's my answer. So again, try this on B if you haven't already to see if you got the hang of it. We want to distribute the -6a to both things in the second parentheses. So that's positive 18a squared and positive 42a. Distribute the 1, and so that'll be -3a and -7. So 18a squared plus 39a minus 7 is our answer. So there we have it. That's multiplying polynomials, both with the distributive property as well as talking about the FOIL method. The big thing with the FOIL method, some people like it and some people don't, but it is a word that gets used a lot, that we refer to foiling binomials times binomials. So it is at least helpful to understand that foiling is just talking about how we multiply together binomials, and if you choose to use the distributive property instead, then that's fine, because they're the same thing. Hope you enjoyed this video.
If you like this video, please hit the thumbs up, and feel free to check out other videos. I've suggested one somewhere on the screen. If you want to know when I post new videos, hit the subscribe button, and you can also follow me on Twitter at KSteveMath. If you have a math question that I haven't answered, tweet me a picture, and I'll try to answer it. Thanks for watching!